let's go for the fastest example code yet, or at least in a while. I'm gonna start with an array. I'm gonna make things a bit more abstract today, at least for the start. And I'm just gonna call it numbers, and it's gonna be just... Let's keep it small numbers only. Good enough. And now I want to sort this array, and for that we have luckily the array class, which includes a sort method that can sort an array in place, so it doesn't need to create a new array and make a sorted list. It can just sort the existing array. And we can look at the output to just verify that everything works, and we do in fact get a sorted array. We do. 1, 3, 4, 6, 7, 8. Looks sorted. Goes just from small numbers to big. Alright? How exactly is it sorting this? The specific algorithm is not what I'm talking about now. I think it uses quicksort, or at least I think the standard libraries use quicksort as the standard sorting method, but I'm not too sure. Doesn't really matter. It's a sorting algorithm that compares different numbers to determine which are greater than others, and based on that changes their position. That's the important bit. It checks individual pairs of numbers to see which of these two is bigger, which do I have to move further to the right, which further to the left, that stuff. And while I don't want to influence the exact sorting algorithm, because it's pretty good and it's doing the correct thing, I might want to change how these numbers are compared. Right now I'm sorting just simple from small to big. Maybe I want to have it in reverse. And sure, there are other ways to sort this in reverse, or just reverse the array entirely after that. But maybe I want to do that while sorting. Maybe I just want to treat the system as a smaller number is a bigger value, so to speak. Maybe these aren't just numbers, maybe they represent something. Like a score, like this is first place, this is sixth place, something like that. So smaller number here means actually bigger and should be later in the array. And your first instinct might be, well, now I have to create a new type to wrap that data in, and that type needs to offer some comparison. Or I need to create my own sorting algorithm. But of course there's an easy alternative. Sorting accepts some other parameters. There are overloads that we can use, and one of them expects a specific type. And I'm gonna create that type, or create a class that implements that type, because it's an interface. Number sorter, let's call that sorter. IComparer for integer, it's a generic interface. And it has this one method compare. And we can now add a new number sorter, like so, pass it on to this sorting method. And what will happen now, whenever this sorting method needs to compare two numbers from our array, it will pass it through this method compare. One is x, one is y, and it will return a value that tells it which one of the two is bigger or if they are equal. If you're not familiar with that comparison method, basically it's also included in the types themselves, so I can do this, for example. x.compare to y. A lot of types already have a compare to method built in. And the return value is gonna be a 1, a 0, or a -1. And if you're like me and have trouble remembering which number meant which, 0 is pretty easy. 0 means both are equal, but I tend to always forget which means x is bigger, which means y is bigger. the way you can imagine that is if... Well, let's write this out a bit differently. Let's write this in context of an if. So this is gonna return 1, or a -1, or a 0. And the way you use it is, if you want x greater than y, you make the result of this, the comparator method, greater than 0. You want to see if they're equal, check if this is exactly 0. And if you want to check if x is less than y, check if this is less than 0. Or you can make less than or equal, or greater than or equal. So basically, if you use the result of a compare, or the compare to method, you always choose some operation to 0, some comparison with 0, and that operation will give you the same result as if you were to make that operation on your two values directly in that order. So whatever I get out of here, the result will be the same as just that operation directly to our x and y. So if we return a 1, that means x is greater than 0, than y. And we can just do that with a simple if. Let's just recreate the default mechanism first. If x is greater than y, return 1. And if x is less than y, return -1. And if they're equal, we just return 0. Right, so we just run this code again. The numbers are still sorted from small to big. We wanted to reverse that, and we can just flip the signs here. So now the system will think when x is greater than y, the system will return a -1. And a -1 means the sorting algorithm thinks that y is greater. Because that's what the definition for this method is. -1 means the second argument is bigger. So if we execute that now, we get still a sorted array, but in reverse order. When changing the order isn't really anything interesting. We can, however, change the meaning of the comparison completely to something that's not the number itself. Well, kind of. Let's say what we compare is not the value of the number directly, but like a modulo operation. Actually, we can rename that later. Now let's do that now. Modulo sorter. And we're gonna have the public and mod. And initialize that from the constructor, of course. And let's say 5 for now. Well, let's go for 3. Mod and y equals mod as well, and then return exactly. We just use the compare method from the integer class. We don't have to make those if statements ourselves. Keep in mind the x and y, they are value types, so we don't actually change values inside the array by doing this. These are just copies. So the actual array is not changed by this, value types. So we can just reuse the existing variables, we don't need to create something new. And we want to actually compare the modulo with a specific value. Sort that way. We do this now. This is the array we get. And this doesn't look sorted, but if you think about it, we have a mod 3. So everything that's divisible by 3 directly is at the very start. 6, 3, those are divisible by 3, so the modulo with 3 is 0. Then we have 1, 4, and 7. And if you make a mod 3 on those, you get 1. And 7 and 8, if you make a mod 3 on them, you get 2. Actually, you don't. 8, you get 2, not the 7. My mistake, sorry. And if we can change this up a bit more, let's do it to 5. Get another sorting. Can also just do mod 2 and just split it into even and odd numbers. Lots of freedom. And this comparison we provide here is not limited to integers. We could have an array of some completely custom type we defined. So let's say we have public class, let's make a class dummy and public string foo. That, and we're going to create an array of that. This is going to be new dummy A, new dummy bar, new dummy with an empty string, new dummy lorem ipsum, that. And that means we can also change our number sorter. Actually, we don't use the number sorter, we create a new comparer, public class dummy comparer, that's more fitting, which is comparer for dummy. Yeah. We still have to include the method and the autocomplete here, or the refactoring tool already provided me with a comparison for the two. Which is pretty important because dummy is now a reference type, it's a class, so we have to contend with possibly having null. And yeah, the usual logic is they're both null, they're the same, and if one is null, null is treated as less than an actual instance. So if y is null, then x is greater. If x is null, then y is greater. If they're both null, then this would be true as well, and it's just null. But the reference equals, I think I've mentioned that in a past episode, is literally, is it the exact same address in memory? Is it the same reference? So it's a safe way to compare if it's literally the same object. It doesn't really compare if they're the same logically, if they have the same values in a certain way. That's what we actually have to write in here. The string compare would be one way, just compares if they are the same string in here, but let's do dummy comparer. We do something else. What we want to compare is x.foo.length. We compare that to y.foo.length. We've already excluded the possibilities for either of them being null, so we can safely use them here. We don't have to make any null checks anymore. Yeah, we just sort them now based on how long the text is. That's one way to go about this. So let's quickly change this debugger display, and that's just going to be. Ooh. It's going to be a bit easier to read later. Another way to compare would be the string itself, yeah. What else? We could compare x.foo. No, we use the count from link and c equals, let's say, how many a's are there? X a's, and then we're gonna have y a's, a's and y a's, like that. And we have a new sort. You see, these two have the least amount of A's and these two have more. So with a custom comparer, we can provide this sorting algorithm a way to sort things to determine what is bigger, what is smaller, without including that in the class itself. We don't have to provide anything in here. We can provide a specific logic we want for this one sorting algorithm, for this one sorting action, through this external class we provide. And this principle of we do generally have an idea what we want to do. We have sort of an end goal defined, but the specifics are not included in this class itself, on this method. We provide some specifics from the outside. We provide an algorithm of sorts. Like the sorting algorithm is included here, but you could imagine that we have another class we provide here that defines a sorting algorithm in some way. Like how do you sort in general? All we did so far is just provide a specific class that determines how do you compare two different values of a specific type. And this is a pattern that exists and is more formalized in the strategy pattern. So you separate the actual action with the details of how that works. So we see the specifics, how do you compare two values, as additional information, as a specific strategy for comparison that you provide separately, that's not baked into the actual sorting. And that leaves you a lot of freedom, because I can now just use different comparers to change how I want to sort these values, but they all use the exactly same sorting algorithm. So if this is a very good sorting algorithm, which I think it is, you can take full advantage of that, despite having different situations that have to deal with it. So very convenient. By the way, comparer, if I don't provide one here, if I just do this, what happens in the default case is it will actually use an existing comparer, which is a default comparer you could also get with the comparer class. This is a default comparer, which, of course, for our custom types doesn't make too much sense, because it doesn't know how to compare them. Besides just, okay, is it null? Are they literally the same? What address have they? I actually don't know how it determines that. Maybe just based on the actual reference? Like how far in the memory is it down? Or, I don't know. But yeah, default comparer. In case of integers, that's well defined. The system knows how to compare integers, it's just literally bigger or smaller. In case of a custom type, I don't know what the default will actually sort on. So in that case, it's better to define your own comparer. You could also, if you're too lazy to create a full class like I did here, use the comparer class to create a comparer, sort of. And what I can do here is I provide a method, a delegate, or in the simplest case, I'm just using simple lambda expression. Start foo dot compare to y, like that. So I have a delegate that I provide to this create method, and it will create a special comparer class that internally calls this lambda whenever we call the compare method. So it's just wrapping around this. But you can even make it simpler than that, because the sort method can also accept directly the comparison method. So we can also provide a lambda directly for this specific method. And the same principle, by the way, for comparers also exists for other mechanisms, also including other sortings, of course. Like for lists, for example, the default sorting, you can also provide a comparer. Or for different string methods, there are a lot of things that have this IComparer in use in some way or another. Let's get rid of this code because we don't need it anymore. The idea that we provide logic as an object can be used in other ways too. For the most part, when we pass on an object, what we're interested in is passing on the data, because the logic is kind of expected already. Like I have a specific class, it has a very specific logic internally, and if we have different classes, then different classes that inherit from the same base class or implement the same interface, it's usually about they store different data, so the specifics of how they apply this algorithm has to be different, but they do generally do the same. But of course, you can also change it to they all store the same exact data, they just treat it in very different ways. Or you can just have it as they don't store any data, and these different objects are purely logic, purely instructions, code how to do something, like different algorithms, like the comparers I had. So providing different objects, even if they are all linked together through a base class, a common base class or interface, is still a very big, powerful tool for switching out logic. And I'm trying to phrase it very vaguely, but I think that's more confusing, because it has a lot of applications. Of course it has. We just saw one of them. There's another application where it's kind of cool to use, though I rarely do, but I still want to show it. And for that, we're gonna make a more extensive example. Can't let that drop. Have to somehow lose some time here. Let's say we have a class damage. And damage will have public, not static, string, public string amount. Good, let's just make a field, public, not balance, string type. So damage has a specific amount of damage. Actually, that should be an integer, not string. What am I doing? And a type. So I have different damage types, and they can all hurt me with the different amounts. And now I want to have some mechanism, some formalized mechanism for protecting against damage. Like my player can pick up armor or specific pieces of equipment that provide protection. Maybe there are buffs and enchantments and magics and whatnot. Environmental effects that all provide some amount of damage. They all differ in how they provide damage, provide protection against damage and what they can protect against. But we can put all of that together by, first of all, arranging maybe, let's use a base class, an abstract base class for now. That's good enough. Protection. Just formally, we have this concept of protection, provides protection against damage, and it can public void reduce damage. Actually, we don't make any implementation here. It's an abstract method, public abstract space class. So formally, any protection will just get this method that we pass on damage to, and it will internally then reduce that damage based on its own determination. Like public class armor, just standard metal armor maybe. And this is going to be a protection. And to reduce damage, we're just gonna check if damage type is not magic. It provides protection against physical attacks but not magic. And if it is not magic, any other damage source, then we can do damage dot amount. Let's reduce it by 20. Whatever damage we get, if it hits an armor, it can reduce the damage by 20. Sounds good. And let's do something else. Let's say I have some enchantment through an equipment, or maybe directly, if the player got enchanted as a whole. And they can provide damage only to magic. and it's not reducing it by a specific amount. We're gonna do that by damage.amount times 0.8. Have to cast it down to int, of course, but this provides also 20 protection, but 20% of the total, not 20 in total directly. Not 20 points of damage, 20% of this damage. So it's more effective against high amounts of damage, less useful if it's just very low barriers. And let's say I create some damage now. Damage. It's new damage. 50 damage. Sword damage, for example. And now I also have new armor. Let's actually put that in an array. Let's collect them all in an array. Protections, yeah, sort of. Only not that. We're gonna have a new armor and new enchantment. Right, those are different types of protection we have. And now I can iterate through these and just go protection dot reduce damage, damage. Right, actually also let's add debugger display here to make it easier. Display type and amount. Okay, did I forget anything? No, I don't think so. So we can see damage is now 30, which makes sense. It's a physical attack, it's not a magic attack directly, so the armor will reduce the damage by 20, 50 minus 20 is 30. Enchantment will not do anything because it's not magic, so it doesn't do anything. Alright, flip it around, let's do magic instead. And magic will reduce by 20%, which it did, down to 40. And the armor didn't do anything because it is magic, which it can't protect against. So that's cool. Let's do one more. This one is getting a bit more interesting now. Let's say I have a special cursed ring as a protective source. And the reason it's called cursed is because it can only affect damage, or it only activates when the damage type is arrow. The ring of Antibo. So when we get hit by an arrow, the damage gets flat out set to a specific amount. So if there's a very dangerous arrow coming at you, well, it's only 15 damage now. But even if it's just a fly, it will still take 15 damage directly. And the special effect we want is this 15 cannot be reduced anymore. This is flat out the damage you take directly. It's more like the ring protects you against the arrow, but using the ring itself causes you damage directly. That's why it's cursed. But that has an interesting side effect. If I add the ring here, on normal logic, if I try arrow now, we produce a wrong value. We don't have -5 damage. We should get 15 damage. But of course, arrow is not magic attack, so the armor also reduces the damage, the 15 damage we get from the ring. That's not how this is supposed to work. I'm sorry, this is not how that's supposed to work. So we have to add some method of telling our system that we don't want any other damage calculations anymore. We're done. And, well, easy way to do that is just return a boolean. It's damage, and by default we're just gonna return true. Bool, that's also gonna be bool, and we return true. We return true, it means, yeah, everything is fine, reduce damage, go to the next layer. But for the ring, we can actually have two different return types. If we do deflect an arrow, return false. Please do not do anything anymore. Otherwise, return true. If it's not an arrow, we just ignore everything and say, yeah, please continue with your damage reductions. And we have to now include the check here. If it's not true, so if we get a false back, then break the loop. So if it's true, then this if would evaluate to false and we just go to the next one. But if we return a false, then this statement is true and we break out of the loop. So with this logic, the arrow works. We get exactly 15 amounts of damage despite having armor. Well, this is pretty stable already. I mean, sure, we should probably do things like make sure we can't get negative damage. Unless that's a mechanic in of itself, like we treat healing as negative damage. Maybe damage and healing are the same thing, but anyway. What's bothering me more this is, if I want to calculate the protection effect, I always have to use the entire array of different protections I have. So I need to carry on this array or this list or whatever I have of different protection elements. And I have to always loop through all of them and make sure that I remember to check the return value. So I have to always carry this around and do this loop whenever I make any damage calculations. Which is probably not that bad, because you likely have some central location where you do the damage calculations. So you likely only have to do this once, maybe twice. That's fine. But we can make it a bit more convenient. And to make this more convenient, we can rely on a technique we haven't touched since we learned about arrays. But if you remember way back a month ago, before we introduced arrays, how did we store large amounts of data? We used a linked list. And with linked lists comes another feature that we can use instead of loops, recursion. So I'm gonna switch things a bit around here. I'm gonna take our abstract class and first of all, we're making this into a linked list. We're gonna store private protection. We're gonna store a reference to another protection element. The next one. It's a simple one-way linked list. And we're gonna add simple method, public void set next, protection next. Next, like that. And so we can get rid of this array for now. Well, kind of. We could still use this array and then the loop to initialize everything, but there's a more convenient way we can do that. Actually, for that, we'll probably do that here. Slightly more convenient. Let's call it public static merge. Not merge, protection merge. Protection merge, and we're just going to use the params protections, and in here we go. We need to go through a loop. I'm just going to assume that this is not null and there's at least one item and all of that. I'm not going to bother with all the fancy correction for now. At all. And let's go with protection next. Yeah, like that's fine. Equals 0, and then we go protection dot set next. Actually, we could just go for next directly. Next equals next, and then next equals protection. Oh, no, actually, wait. This is wrong. This would not make too much sense. Let's do this in this way. Just do it like that. And I personally prefer it this way. Personal preference doesn't really change anything, it has zero impact on the code. And now we do that manually. So we go protections I dot next equals next. Then next equals protections I. The reason I do it this way is so that we can call this in here, protection merge. And it will basically sort them in the same order we write them in here. So basically we'll take the enchantment first and set the next to null, because that's what we start with. And then next it's gonna pick up the armor and say the next item after the armor is gonna be the enchantment. And then we're gonna add the ring and add the armor, which includes the enchantment. So what we get in the end is the ring, which internally points to armor, which then points to enchantment. So this reverse for loop is just so we have the proper order of items. Yeah, and then return protections 0. Again, I'm not gonna bother with checking the length and if there's at least one item or if there's anything null and all that. And exceptions if there's nothing. We just pretend this is gonna work. And next we're gonna change out this loop, because we don't want to have a loop anymore. We want to simplify things with a recursive call. So I'm gonna call reduce damage. All right. To make my life a bit easier though, let's move that into its own method. So this is internal. Internal. It's gonna make that protected. So this is just the method we override in each class to define just the specific parts we need. And then there's the overarching method, public void reduce damage, like that. And gonna call reduce damage internal in that. And if that is true, so we do continue with another item and we do have another item, then call reduce damage on that next. Like so. Ah, that works. So that's where our recursion comes in. This is the recursive method, and the recursive method is using the abstract method in here to make the actual damage calculation. So each class can simply change that specific behavior, and we don't have to worry about the larger recursion and linked list inside each child class. So I can just do reduce damage in here. Let's do a breakpoint. And damage is 15 for an arrow. Let's retry for sword. 30, that's correct. Magic. 40, that's also correct. So we just merged all that together into one single object. That makes it a bit easier for us to move it around. Because we have one single object that contains all the different types of protection we have, and we call only once this method that reduces the damage. We don't have to worry about any return values or anything, we just know it will take care of that. All my protection is in this one object and it will take care of everything. And in the background, I can just create new types of protection that override this method to do their own specific thing, and I know the end result will be correct. You can also add another piece of armor, for example. Let's say fist should be go down to 10, and yep, I have 2 pieces of armor now. And this way I can just combine different kinds of protection, and the system will just work out correctly, which is very convenient. Of Of course, the order is important. So right now, we start with a ring, and when the ring decided, it's okay, you can continue, I'm not interested in this type of damage, only then will these continue working and do their thing. But if we move ring, let's say down here, we still have the old issue. So if I go for arrow now, I mean, we don't really have an issue, but kind of unnecessary. We're lucky in this case because arrow does cause a very specific damage, so the reduction we get before through the armor pieces is not seen. You can't notice it. It's not noticeable, but it is there. The armor pieces still reduce the damage even though the ring should forbid it. The order does matter. Sometimes. This type of thing though is we have different objects. We just make a simple linked list and these different objects refer to one another, potentially. Maybe they do, maybe they don't. This is also another pattern. This is a chain of responsibility. And honestly, it's not a pattern that I use often. Personally, I usually stick to, I have a list and I iterate through that with a loop. Usually. There's one case in which I actually used this type of setup, and that's because it was kind of already there to begin with. It was for an HTTP client, and the standard HTTP client has this thing called message handlers. Basically, any HTTP request you have that you send out passes through a handler that you can use to modify it. You can add header information, for example, authorization header data, or make validations against the address and whatnot, and do a lot of very useful things. And at least the current statement was that you should use a socket handler because of socket exhaustion. At least if you're using HTTP client directly. I mean, if you're using some existing library that deals with that, I think ASP.NET, for example, you don't need that because it's already handled everything. But yeah, if you're doing that, I should have a socket handler, but we also have our own handler that provides some functionality. We use that special handler we wrote ourselves to make some validation against the URL we talk to. Not because we want to make it secure for the user, it's mostly just to catch our own errors, because we don't want to accidentally contact some weird website. We want to make sure that if we send requests, it's to our own servers, because that piece of server needed to talk to our servers to download updates and whatnot. And just to catch coding errors early, we just check the URL, visit the correct address, and if so, handle the authorization stuff, fix in the header data, and then pass on. We also use it for testing. That's another special handler we use. That was for mocking different responses from a server. The handler just pretends you contact the server and you just got a 404. How does your program react? Or you wanted to test the download, so the handler just pretended like the server answered and you hear the download stream for the download. And you can test how our system handles that. Different download speeds, interruptions and whatnot. Very useful. But all these different handlers get combined. They work on top of each other. And that works through this type of strategy where they refer to one another. You have a handler, and internally in that handler is stored another handler. So the handler does first its own job, and then it calls the handler that itself stores. And that stored handler might have yet another message handler that it calls once it's done. It has this entire chain. And every time you call a handler, it might decide that actually I have to abort. We can't do this anymore. That's the wrong URL, that's unsafe, I don't allow it, abort. And maybe log. So it can be useful. Sometimes you will have systems that already use it and you have to just integrate into that. It's a very simple, straightforward thing. It's just a linked list with a single recursive method in this case. But it is a full pattern. Let's drop all of this again. Talk about another thing. Let's say you have some UI. because you have a game and user needs to interact with it. And whatever that UI is like, you will have interaction from the user. Even if it's purely text-based adventure in a console, that is still a user interface. Maybe not a graphical one, but it is a UI. And the user interactions will be triggered by something. User presses a button, maybe just a hotkey on the keyboard or wherever, to drink a potion. They have something in their inventory and you have a hotkey to say, hey, drink a potion from your inventory. Or maybe they go to an inventory screen and see the potion and then click on there through a special action and say, use this. Or you have the normal menu just for changing settings or saving or whatnot. You also have the user clicking on an item or using the enter button when using the keyboard maybe, and then triggering a specific menu action. The most straightforward method would be you have some system that reacts to I'm pressing a key, and you tie to that directly some code that is executed. Or you have a menu item and you say, when this menu item is activated, do exactly this code. And you have another menu item that says, hey, do this code. Thing is, while you develop, and later if you extend or debug, these menus and hotkeys and whatnot will probably change. You add new ones, remove existing ones, you just move their position or meaning. And if you tie the code directly to these different UI interactions, things can get a bit it gets a bit harder to navigate everything and refactor everything. And maybe you lose track of where is what, where did I store what. So there too we have this separation that we had in the beginning of, we have the general logic here, but the specifics of how this works is provided through an object externally. And a common thing that happens for a lot of things, but especially for UI, is that you wrap this action that's supposed to be triggered by something else in a special type of object, and you then pass on that object, this very generalized object, to a thing that can use them, that is triggered by something, which itself is very generic. So let's start with this thing that represents an action, and we're gonna just make it an interface, and I'm just gonna be UI action for now. What? UI action, and oh wait, it's interface, and it just has the method perform. Just do an action. And I'm gonna make a class, and that might be inventory action, like drinking a potion. UI action. And perform will now do something. Use item from inventory, for example. Not gonna bother with the implementation. Or maybe class menu action. Again, big C, why? Action. UI action. And this is select menu option, for example. Menu section? No. What is going on? Can you not, please? Thank you. Talking to my hands. It's sad if I have to speak to my own hand. Not even I am listening to myself. So we have different types of action. And now we need, on the other hand, different things that can use it. And let's make an abstract class again. The class user interactive thingy. I don't know. And this user interactive thingy can private, let's make it read only, UI action that we provide in the constructor. Actually, no, let's keep it protected. It's abstract at all, protected. And we're gonna create two classes. Let's say we have public class menu. And then another class, public class hotkey, which is also a user interactive thingy. And what these user interactive thingies can do is they have some method, public void trigger, triggered by user, let's put it that way. So they press the hotkey or interact with the menu in some way, mouse click, whatever. And then we can just do action.form. And what that gives us is I can first define some actions, like can have an inventory action, or I could have menu action. And now I can create a user item like a hotkey, and this hotkey then can receive the inventory action. Or I can create a menu which could also get the inventory action, even the exact same one. There might be several different ways I can use it, right? Like the potion, I can trigger it through the inventory screen, or I can use the hotkey while normally in game. Or for the menu specifically, of course, menu.var, menu, we might have menu action. And the thing is now, the actual UI items are separated from what they do. So you might later change your mind that this inventory doesn't let you directly use the potion, it does something else in there. And you just assign a different action to this menu without losing the menu itself. And the action is also still preserved, the logic, which is stored in this special object. So the hotkey is not influenced by that. You just assign something different in here. That's fine. Maybe it's a different inventory interaction then. Same with the menus. The menu might be gone later on, I add additional menus. I can simply change what they mean. And if I change the behavior exactly, like what specifically does happen, I don't have to bother about, okay, where is this defined? Is it in the hotkeys, in the menus, is it in both? I know, okay, no, it's this specific inventory action, so I just change the code in here. And wherever I reference this specific object, they will use the new behavior. So I separate the logic out into a separate object, and I combine them during runtime into one object that has a reference to it. It's like during runtime, dynamically creating a new object almost, because you can freely choose what is the code that this object execute, or can execute, or is executed internally. Sure, the specific methods names are somewhat given, we're restricted in that, but the code that's in there can be completely different. And there may be code that's just not filled. Maybe there are different methods and some of them just don't do anything. And so we can have different amounts of code, different types of code, completely different behavior from very specific predefined building blocks. That's maybe a good way to look at it. We have different building blocks that define very specific things, like something you can do in the inventory, something you can do in the menu. And other building blocks are a key you can press to do something, or a menu you can interact with to do something. And then in runtime you combine, I have this thing that can do something, and I have something that can be done, and combine them in one item. And during runtime, this is now a thing that does something. If you're working with UI, like actual UI libraries, like the C# libraries, for example, this interface would be probably ICommand. And in general, this is the command pattern. It's very useful in UI, but it can be used in other contexts as well, of course. Like the general idea is just you trigger something, you have something that can be triggered, you keep them separate when you actually write the code, and then during runtime you can pick and choose, combine them. Name drop. Oh, maybe of note, the name would be execute then, not perform. And also pretty interesting, we have not just execute, but can execute as well. So we have still the method that executes something, the same way we talked about for so far. But with the can execute, we deliver feedback in the other direction. So with the execute, we start from the menu, and the menu passes on to something to execute. But on the other way around, the menu can also ask the command, can I actually execute you right now? Is it possible? Like a menu might be blocked by something. Maybe there's a message box popping up and you have to confirm something first as a user. And during that time, you might want to block a certain hotkey, because you don't want users to accidentally trigger an action if they are not aware that the action is even possible. If there's a message box confirming something, you don't want to accidentally throw away your best weapon, right? Something like that. So in that case, can execute can be used by the containing thing, object, to determine if it actually should offer the execution. And for something like a button and a menu, that could mean, do I look grayed out? For example, am I visible at all? During the game for hotkeys, maybe you have little helper UI that shows you, hey, press this key to do this thing, and you just block it out or remove it entirely. So that's what you see in C# at least. I'm not sure how other libraries do it, but I think they probably have some similar concepts of, you have this command, you decouple the UI element, that's what we should be calling this, UI object, UI element, decouple that from what it actually does, from the code that reacts to you reacting to the item, and you need some way of triggering it to cause the action to happen, and you should be able to figure out if you actually should be allowed to do that, because in the UI you want to give the user some feedback of what they can and cannot do. So visually or any other way, telling the user you can perform this action, you cannot perform this action is very useful. So I'd assume that these two are very common in some way. Oh, the ICommand, by the way, also has an event that is triggered when the value of this changes. So it's not like you have to specifically check all the time, can I do this? But you can hook into the event, and then once the event is triggered because something changed, the menu item, for example, is informed that, oh, hey, you should probably disable yourself for now, at least. Yeah, that's the command pattern. And that's all 3 patterns I wanted to talk about today. But since we have a bit of time, maybe a slight detour. Because while preparing this, I thought about demonstrating another feature first, and well, there's a better way. And maybe I can show you something interesting. So let's say we have public event. Public event. Let's just do normal action. Action. Some event. Okay, yeah. Can be now. So usually some event. Public. Static, like that. Some event. If I now add a method to do something in here, usually the usual logic would be I trigger some event from somewhere, and then internally it will just call this method that I registered one by one for every single registered method. Just whenever I do this plus equals, I register a delegate, a specific method, something to call, some code, and this entire list will be iterated through when I call the event. So when I hit this, the method is called. Something you might not be aware of is that action, let's change this. Yeah, for now, that. They can have parameters. I think that much we discussed already once. Value, and let's put in a 10. And now I get some values. Event arcs is usually the thing, or at least some subtype of event arcs. Well, something you can do when you have a class and not just a simple predefined value type, but your own custom types. Specifically a class, though, some reference type would be important. Public class, some event arcs, which are event arcs. I don't actually need to inherit from event arcs, just thought I should maybe demonstrate. Let's remove that again. Let's make it a bit cleaner here, just to demonstrate better what's going on. And then we're gonna make public bool continue. This is gonna change on there, and we're gonna do new some event arcs. And we're gonna start with continue equals true. This is not too common, but it can happen. There are cases where it's used, I think even the standard library. Can't remember. Oh yeah, that was also UI. For when there's an event in, was it WinForms or WP? I think in both. When you close a window, there's an event you can hook into that is called when the user wants to close a window, or when the user, or generally when the window is about to close due to something. Not the process exits, but just specific window is closing. And in there you also get an object with a boolean. And the interesting thing with that is, by changing that boolean, you can basically deny the closing of the window, which is interesting. But more interesting here, I can check the value and I can decide, no, don't continue. And if I have some more types that hook into this event, different objects, different classes, different contexts, they all get executed one by one in the order I added them, and I can check this value, value.continue. Then we change the value to false and do stuff. So I set this to false, so the next method that calls was called and checks this value now will see a false and will not do stuff. Essentially, we have through this object that they all can see a shared variable that all of the different event callers see, and they can communicate through that. Normally, this registration is pretty kind of anonymous. Like the different methods that you registered don't have any connection to one another. I don't know what else is connected to this event, is registered here. What came before me, what's coming after, I don't know. But through this reference type, I can now be sure that this one boolean is seen by every single registered event handler. And that allows me to communicate through that. Even if the communication is pretty simple, as in, please don't continue. I got this. Please don't do anything anymore. And this would be something you might want to do for the damage. That's where I thought I might introduce it, for the damage types. A player gets some damage, and so we call the reduce damage handle damage, and it would receive the damage class and do the reduce damage inside the event handler here. And for the ring, it would then set a variable to deny the next event handlers to call. Which is a pretty interesting idea. I've seen exactly that principle before in professional software. It is a bit weirder in there though, because there are multiple stages to this. Do I continue? Do I not continue? Because you get an event at least twice, at least. And so there's a bit of a protocol to that. And you can also change the order in which different pieces of the software are called, and that's a bit weird, but yeah. The idea is though we have different pieces of code that can talk to each other about, do I still continue in action or do I leave it out? And that would be similar to the chain of responsibility. You have different handlers that do their own thing on this one shared object, or generally on one thing, and they all get called one after another. They can cooperate, or they can ignore one another, or they can even affect the entire chain using a shared variable. And while that is interesting, I thought this might also be the chance to show you something weird, which I'm not sure I showed before. Events can have return values. And honestly, let's do func string. That maybe. So func when action is just a common delegate for just a void method, and func is a standard delegate for a method with a return value. So the generics in first are the arguments. The last generic in each func is the output value. So these events now have a return value. And I'm not sure how aware you are of that, because it's just an interesting feature that I don't see ever getting used. Return. I don't know. Look. The way this works is each method gets called and produces a return value. And if there's another event handler coming after that, that value gets overwritten. So this is something you can do, but it will only output the return value of the last method that is called, the last event handler that is called. So I'm not really sure how useful this is. Though if you have an entire chain, example, the damage handler chain, you could output the final damage as a return value. And you would know that it's the damage value of the last event that is called. But of course, with the ring, you might interrupt the entire chain early, and in that case, things get a bit wonky, but yeah, just decided to show that. Things I try to work out before a stream. Can I demonstrate this? Decided events were too weird. Go with the direct route. Honestly, that's all I got for today. Didn't think we'd get through this fast. But the code just worked, so that's good. Yeah, that's all for today. Guess have a lovely Sunday afternoon, and till next time.